In this video, we will show another example of using Apache Spark, this time for more of a scientific computing. It is definitely an iterative algorithm that we want to show how Apache Spark can be used for. Let's say our goal here is to do a logistic regression algorithm on a data set. So here's an example. Let's say you have a set of data points, and let's say each one has a label. Some of the data points are positive, some of the data points are negative. They're just, say, random bits of data. Now, you and I look at this and we say, oh, it's very obvious. These stuff are one class and these stuff are another class. But of course, we are humans and computers have a little bit of harder time trying to figure this out. So logistic regression is one algorithm that tries to do this. And to be able to do that, it starts from a random guess. So it says, hey, so this is my target. And it starts by guess saying that, hey, this is my initial guess. I think whatever's above this line is one class and whatever's below this line is the second class. So the initial line is random. Well, we can look at it and say, hey, this is obviously wrong, but it doesn't matter because the algorithm iteratively works on the answer and fixes itself. So the first iteration, what it does is it finds, in each iteration actually, it finds the distance of every single item to the line, and then it fixes the line a little bit by saying that, oh, it's not quite balanced. Let me fix the line a little bit. So in the next iteration, we have this slightly slanted line. Again, we move a little bit more, a little bit more, a little bit more, a little bit more, until the algorithm says, oh, OK, I like this. So let's see how we could write this algorithm in Spark. And here you'll see the power of Spark in doing iterative computations on huge data sets within very few lines of code that look very easy to understand. So let's see. I start by creating an RDD, saying Spark, read from a text file somewhere on HDFS, for example, I assume. And again, remember, we are using the builder pattern, so we can take one RDD and do dot something, dot something, dot something, and it just works out very nicely. So I load the data. On each input item, I run a map function. What function do I use? I use the read point function to read the data points. And then I say, hey, let's cache this. OK, fine. So now data RDD contains a cached set of data points. And I can run iterations using information stored in data. So you can see inside my loop here that I'm running an iteration. I am using data RDD. And it doesn't need to load the data again and again from hard drive. Once we've cached it into memory, it remains in memory. OK, let me clean this up and continue. So the next thing I do is I say, let's have, now that I have the data, let's create a random line. So here I'm saying that let's take the vector package and create a random line, and let's call it the W line. That was the line that we saw in the previous picture, turning around. Now I start my iterations for I from 1 to the total number of iterations that I want. I can do iterations. Inside each, I can say, hey, let's make a new RDD. Let's do a map transformation on the first RDD, on the data RDD. Inside my transformation, I run the regular algorithm for for logistic regression. I'm not going to cover that. There's like, lots of different places. Just you can see Wikipedia page for the logistic regression algorithm. But basically, it just does some sort of a inverse distance computation. So it finds the distance of each element inside the data RDD, and we show this by P. So we say, hey, take one element from the RDD and by this operator, equal this. I say take one element and do the rest of the operations on that. Okay, so what's the operation? I take that element. I take the x out of it, and then I take the y out of it, and then I multiply by w being my line, exponential 1 divided by that. That's the mathematical computation. Doesn't matter much here. Just the idea is that you can run this function over and over on this data set. Now, the interesting thing is that you can do a map and you can do a reduce. Reduce being an action makes the Spark engine go ahead and do the computations in parallel across the cluster. So just a couple of lines, and we can see that writing such a, these number of lines is actually not that hard. I don't know, maybe it'll take you like 10 minutes, 15 minutes, half an hour to write this. And you can get your data, insight into your data very quickly. More importantly, running this on Spark compared to Hadoop gets you much better performance. This is because you have cached the data in memory. And if you were running it as multiple jobs on Hadoop, each time you have to load the data again and again from hard drives.